Application to physics and engineering. Hydrostatic pressure and force. Fluid force is the force on an object submerged in a fluid. Laws that determine the pressure exerted by a fluid are follow. Fluid pressure P is proportional to the depth d measured from the water level. D is the distance from any point on the surface to the water level. Fluid pressure does not act in any specific direction. A fluid exerts pressures on each side of an object in the perpendicular direction. For example, take the top surface of an object whose distance from the water level is d. This is the depth of the object. The fluid mass, m, directly above the surface of area A is m equals rho times v, where rho is the fluid density, this is the mass per unit volume, and v is the volume of the fluid body directly above the surface. The weight of the fluid, which is already the unit of force, is defined to be the product of the mass and the gravity, mg. But the mass is rho times v, so the weight is rho gv, but the volume is the area times the depth d. And so the weight is rho gad. Pressure is defined to be the force per unit area, but the force is rho gad, and so the pressure is rho gad over A, which is rho gd. To summarize, the pressure P at depth d in a fluid of mass density rho, or the weight density delta, is P equals rho gd or delta d. The pressure acts at each point on an object in the direction perpendicular to the object's surface at that point only. What this means is that at any point on the object, the pressure acts perpendicular to the surface at that point on the object only. Since the pressure is rho gd equals delta d, rho g is delta. Rho g is in the SI system and delta is in the British or English system. We know that the SI system is used when meters or kilograms are in the problem. The British system is used when foot or pounds are used. The SI unit of pressure is the Pascal, PA, where 1 Pascal is 1 Newton per squared meter, or 1 kilogram per meter second squared. Pascal is small, so usually kilopascal is used. Mass density, the mass per unit volume, is denoted rho, the Greek letter. The factor rho g is the density by weight, where g is 9.8 meter per second squared near the surface of the earth. The mass density of water is rho equals 1000 kg per cubic meters. And the weight density is delta equals 62.5 pound per cubic foot. Sometimes 62.4 pound per cubic foot is used. Observe that in the SI unit, the pressure is rho gd, but in the English unit, the pressure is delta d. Delta is the weight density and rho is the mass density. The weight density is pound, which is already the unit of force. Thus the force is rho gad in the SI unit or delta ad in the English unit. We know that the SI unit is used when the units are in meters or kilogram, and the British units are used when the units are in foot or pound.